Guys, welcome to Math Mastery Elite. Today we are going to discuss a concept from the chapter Continuity. We are going to discuss the types of discontinuity. What are the different types of discontinuity? The first type is removable discontinuity. Now, let us look at the definition of removable discontinuity. This discontinuity occurs when the limit exists finitely, but the function is not defined at that particular point. Now, let us check an example. It is y is equal to x squared minus 1 divided by x minus 1. From observation, we can say that the numerator is x plus 1 into x minus 1, and the x minus 1 gets cancelled out, and the value of the function is y is equal to x plus 1. But the problem is that the value x is equal to 1 is not in the domain of the function. Now, to get a more understanding, let us check the graph of the function. Y is equal to x squared minus 1 divided by x minus 1. This is the graph of x plus 1, and at exactly the point 1, the graph is undefined. So it is a removable discontinuity at this particular point, right? Because x is equal to 1 is not in the domain. Now let us check the next discontinuity. The next discontinuity is jump discontinuity. Let us look at the definition of it. A discontinuity where the left-hand limit and the right-hand limit at the point exist but are not equal. What does this mean? The limit of the function doesn't exist, right? As we've discussed in the previous videos. Now let us check the example of this. The example is the greatest integer function, step of x. Now let us check the graph of it. Now the step of x function looks like this. Exactly less than 1, we will be getting the step of x function as 0, and when it is greater than 1, we are going to get the step of x value as 1, and so on and so forth for the remaining values as well. The step x is discontinuous at every integer. The next type is infinite discontinuity. Let us look at the definition of it. Now, as an example, we are going to take the 1 by x function. This function is not defined at x is equal to 0. Let's look at this function. The 1 by x function looks like this. When x is approaching to 0, it approaches to infinity. Now we can say that 1 by x function is an infinite discontinuous function. Let us look at the other discontinuity. This is the last type of discontinuity, which is oscillatory discontinuity. Let us look at the definition. A discontinuity of the function oscillates between different values as it approaches the point, and the limit do not settle to a single value. Now we are going to take the famous example of sine 1 by x. This is a type of discontinuity when x is approaching to 0, the value oscillates between minus 1 to 1. Now let us look at the graph of the function. This is the graph of sine 1 by x, and when we look closely at 0, 0 plus and 0 minus, it is discontinuous because there are infinitely many values existing between minus 1 to 1, the limit of sine 1 by x when x is tending to 0. I hope you understood the types of discontinuities with examples. Thank you, and see you in the next video.